start the last portion of the plane curve. Okay, plane curves we have seen so far is conic sections. Okay, in conic sections, ellipse, parabola, hyperbola. Okay, how to construct that? Okay, what are the types available? 4 types we have seen. Then we have seen the cycloidal curves. Okay, the second portion, cycloidal curves. We have cycloids, epicycloid, and hypocycloid. Right. So how to construct that? You know that. Right. The third portion, involute. So how to construct involute curve? So what is involute? First of all, involute curve. See, suppose I have any polygon, a square, rectangle, or pentagon, hexagon, right? Pentagon, hexagon. So any polygon or any circle. Say, I am having a square like this. Okay, this square. It is circumferentially in the square, over the square. I have a thread over this. Suppose I have a thread in the circumference of the square. It is tightly tied with a thread. Okay. We assume that if I am keeping this this is the end, I am going to open the curve. This is the end, I am going to open the curve. Keeping the thread tight over the polygon. Right, polygon also. See, suppose I am keeping tight this thread which is in yellow color. Okay, and I am opening this thread from this end A. Okay, so suppose if I open like this, what will happen? This thread will have a path tightly like this. Right, keeping this. Similarly, now the thread will be like this. Okay, then keeping C as kept tight, C corner C as tight. Then I will start open this same curve up to this like this. Okay, I can open. Okay, the thread, if it is open, thread which is on the circumference of a square, if I open it in this spot along from B as center, I can open it. From C as center, the same thread is opened like this. Okay. B as center, the same thread is opened like this. Right. Up to this. So this path is nothing but the cycloidal path. Right. So the definition is something but if a polygon or a circle, okay, never know, involute. This is spiral curve. So again, it's a spiral curve generated by a point on a cord or thread as it unwinds. Okay, as it unwinds from a polygon or a circle. From a polygon or a circle. The last sentence is as the thread is being kept tight. Right. So I have a thread over a polygon or a circle. I am opening a thread, unwinding the thread. Okay. I am unwinding the thread, keeping the thread tight. Right. So the path is nothing but the involute path. Point I am interested is P here. I am unwinding a thread which is around the polygon or circle. Right. The path traced by a point is an involute path. So where it is used actually, already I told involute, where it is involute curve where it is applied actually, where it is used in reality. In gear tooth profile, okay, I told the gear tooth profile is a very important profile, okay. The gear tooth profile is a very important profile. It cannot have a square gear, we cannot have a square gear teeth, okay, we cannot have a triangular gear teeth, okay. So the gear teeth profile is a very important profile. It will be an involute profile or it will be an cycloidal profile. Okay, mostly I told last class itself, mostly all the gears have an involute profile. Okay, involute teeth. Right, you can see here in this video. Right, the gear teeth profile is nothing but an involute profile. So that is nothing but the involute curve of a circle. The teeth profile which holds the involute profile, it is nothing but the involute of the circle. This is the circle in this body, that is nothing but the base circle, involute of the base circle. So you can see that the profile. Suppose I have a circular, this is a base circle, okay. So I have a thread around this circle. If I open the thread, see here I have the end B. If I open the thread will, keeping the thread tight, the thread will occupy these positions, various positions. Okay, this part. So similarly, the involute of this will be like this. And this part is nothing but the involute. So this profile is nothing but my gear teeth profile. This is okay. So that is nothing but the involute of a circle. Okay, the gear teeth profile is nothing but the involute of a circle, not a polygon. Okay, it is involute of a circle. So why it is essential? I told already. Why it is essential? The gear teeth should have this profile, involute or cycloidal profile. Why? Huh? Yes, that is to avoid this slipping. Suppose you have any other profile while the transmission, okay, velocity transmission has to occur smoothly to another shaft. Okay, if I have a gear teeth profile in the form of involute or a cycloid, okay, then only there will be a smooth velocity transmission occurs from a shaft to another shaft, okay, without slipping. If the load is more in one shaft, there will be a slip in other shapes, okay. So if you have in a gear, if you have a cycloidal or involute profile, there won't be a slip and there will be a smooth transmission. You can see the point of contact of these two gears, you can see it is moving like this. How it is moving the point of contact? It is moving in a cycloidal involute part. Okay. The point of contact, you see it is moving in an involute part and it ends here. At the same time, another gear teeth comes and having contact. Okay. That's the point of contact. Okay. To have a smooth velocity transmission and to avoid slip between the gears, there should be an involute profile or a cycloidal profile. Okay. So mostly in all the gears, involute profiles are used. Okay. So cycloidal profiles are a little bit costlier in manufacturing. Okay. So the other applications, you have pump casing, you can see there is nothing but an involute casing. Okay. You can see inside the pump there will be impellers. The impellers will have an involute cavity. Okay. Through that the water pump. Okay. So in this one there will be an involute opening. Right. So similarly you can see the gas compressor, it is nothing but a scroll compressor. It is nothing but in a spiral form. This you can see it is rolling. Suppose the air is inside, goes inside, but the air it is squeezed and it is compressed and it is moved through this and the pressure can be increased. Okay, it is a compressor. Okay, what the air goes inside to this? Okay, due to this scroll compressor, the air gets compressed and you can have a higher pressure out. Right. So these are all the applications you have. The major application is the gearbox profile. Right. So write down the problem. These two problems. These two problems. Okay. The first one is draw the involute of a regular pentagon of side 20 mm. Draw the involute of a regular pentagon of side 20 mm. Draw tangent and normal at a point on the involute 80 mm from the center of the pentagon. Another problem also, you note it down. Construct one convolution of an involute of a circle of diameter 40 mm. Draw tangent and normal at a point on the involute 90 mm from the center of the first problem is solved. First of all, you have to draw a pentagon. So our intention is to get the involute curve for the pentagon. Okay. So draw a pentagon with 2H pencil. Right, with the right one, draw a pentagon, keeping a side horizontal. Okay, keeping a side horizontal. Pentagon, how to draw, you know it. Okay, draw a pentagon. See here, pentagon of side 20 mm. Okay, pentagon, you know. So how I can construct a pentagon? 72 degree or 18 degree. Easily in your drafter, I can fix my drafter to this end. Okay, so drafter scale. The vertical scale, I can tilt it to 18 degree to the left so that I can get an 72 degree inclination like this. Right. The same on the drafter itself, I can mark the 20 mm. Okay, side 20 mm side I can mark it. Similarly, you see, again you can keep the drafter to 0 setting and move the drafter here. Again the vertical scale, I can move it to 18 degree to the left side, okay, negative side, so that I can get the other side also. So this is my another 20. Then what I have to do? To end up with another final corner, measure it with your compass the same 20 to get the intersection. Okay, from using this corner I can have a 20 mm. Or, okay, using the same other corner I can have another 20 mm more. The intersection will give me another corner. Okay, this is my pentagon. Great. So the pentagon size here is 20 mm. The dimension is 80. It's 20. Right. The center, okay, along I can draw. The pentagon, suppose I have how we can get the pentagon is, center for the pentagon is, I have a pentagon like this. So if you take any two sides, okay, draw a perpendicular bisectors, okay, you see any two sides, you mark the middle of that, you join that to the opposite corner. Okay, this is a construction, our intention is to mark the center. Okay, the construction should not be visible. So I am considering this side, the middle I have taken, so this is 20, 10 middle, I am joining to the opposite corner, you see here, joining to the opposite corner. Similarly, in another side I can take it. Okay, say this side I am considering. Take the middle of that. Okay, join to the opposite corner. Opposite corner is this. Okay, when you join to that opposite corner, this two lines bisects here. So this is like my center. See, normally the center of the pentagon will be below this two corners. Okay, somewhere here. Okay, so always you see here, this is how you have to mark the center of the pentagon, right? So you need not draw all the way, you need not draw this line. Okay, you have to get the middle. So what I can do, you can mark the middle, fix your drafter, just you get a line in the middle, vertically, joining to the opposite corner. Okay, similarly, in this other side, from the other side, mark the middle, then you fix your drafter to the opposite corner, align your drafter, then you draw a line so that you get the center. Okay, you need not draw all the way, you need not show the lines, bisecting lines, right? You just get the center like this. It is very much essential. Okay, always you have to mark it quickly, you have to mark the center. Okay, for pentagons have to mark the center, you should not forget, right? In the clockwise manner. Okay, this is my corner A. From A, this is B, C, D, E. This is my center. What I can do, I have to extend BC. Okay, BA is horizontal. I can keep it as it is. Okay, for my convenience, I am rearranging. Right. So anyhow, you can draw it in your drawing sheet. Okay, for my convenience, I am rearranging because I have to get the envelope here. See here, BC. I have to extend. There is CB. I have to extend it in the negative direction. See here, CB. Tangentially, I am extending like this. Okay, now I have to keep my B. My point B is, I am keeping it here. The A is nothing but my point B. Okay, keeping B as center, BA as radius. Okay, I can draw a curve using compass. This is my B1. Now then I have to extend it. CD. The same fashion in the negative direction. Okay, I have to extend it. Keep C as center, CP1 as radius. Okay, CP1 as radius. I can draw it. I can continue the same on. Right. Then this is my P2. Then keeping extending ED in the negative direction. Right. Keeping D as center again. D, P2 as radius, that is nothing but 60. Okay. That is nothing but 60 mm radius. I can extend the same R. So I will end up the involute point P3. Then I can extend AE in the negative direction to the AE. So now keeping E as center, E, P3 as radius, that is nothing but how much? That is 80. Okay, this radius is 60. Okay, the other radius is 80. 80. This is going to be my P4. So using E as center, E, P3 as radius, that is 80 as radius. You can end up with point P3. Then which one I have to extend? The remaining last edges BA in a negative direction. I can extend BA so that I can get it as a horizontal one. This. Now the final radius will be, keeping A as center, the radius will nothing but the overall radius will be nothing but the circumference of the pentagon, that is 5 sides into 20, that is 100 mm. Okay, using A as center, AP4 as radius, that is AP4 radius is nothing but 100 mm. Right, this is my P4, 35. So by currently drawing a curve, right, this is going to be my involute of a pentagon. You see here, so these segments of involute, it should be drawn in a using your compass. Okay, see here, each segment will have a constant radius. It is not a varying one. So this segment of involute, okay, this segment of involute, that is P to P1, it will have a radius of 20 mm. This segment of involute will have a radius of 40 mm. This segment of involute will have 60 mm. This segment will be 80. This segment will be 100 mm. The overall, you can say, the overall length of the thread is equal to, is nothing but the circumference of the polygon or circle, okay, which you are going to draw the involute. Okay, the overall length of the thread which you have wound around the polygon or circle, it is nothing but the circumference of a polygon or circle. Okay, this length you can see is nothing but the circumference of the pentagon of side 20 mm, that is 100 mm. Right, the circumference of this pentagon is nothing but the 100 mm. Okay, this 20 mm one. So what you can do, otherwise I can segment this into 5, this lines into 5 segments. Say this is 1, first one, second one, third, fourth, this is 5th division. So any pentagon, polygon or circle is given, you can draw a horizontal line, you can divide that horizontal line, okay, you can draw a horizontal line for a length of its circumference, okay, what is this length? It is the length of this circumference, okay, 100 mm. So how many sides you have in your polygon? It is 5 sides I have, so here I have divided into 5 divisions, okay, the first division I can measure it along the first tangent line drawn. Okay, the tangent line drawn is here. The first length of this P1 point P1 will have a distance of the first segment, that is nothing but 20 mm. So then I have drawn a tangent line to the another side. Okay, from C I have to mark the P2 will have a length of the second segment. Okay, that is nothing but 40. Okay, the third tangent line will have a third segment length. Fourth tangent line will have a fourth segment length, okay, to mark the point 4 and to mark the point 5 and end the final end. Is it clear? Right.
To draw tangent and normal for the given problem of pentagon, mark the point M on the involute from the center of the pentagon, measuring 80 mm. The point will be obtained in between the segment P3 and P4, nearing P4. Right. From M, connect M to the center of the cycloid segment drawn, that is P3 and P4. Connect M to the center of the cycloidal segment P3, P4. That is nothing but normal, and draw the tangent at that point. It is the perpendicular drawn to the normal at that point.
Go on to the next problem, a circle. Draw the circle. Here, the notations for the circle. Okay, I'm going to open this circle thread like this. Okay, the overall, the final curve will be like coming horizontally. So the notation I am giving in the anti-clockwise manner. So this is my first segment. Again, horizontal line from point P, okay, that is the 12th point. Draw a horizontal line, that is nothing but a tangent line, okay. So that is going to be the overall final length of the thread around the circle. Okay, what is the length of the thread around the circle? Circumference of the circle. So what is the circumference of the circle here? 125.7, that is pi into d. Diameter is 40 mm here. 3.14 into 40, it is 125.7. Okay, from here 12, from 12, you draw a horizontal line. The horizontal line will have a length of 125.7. See here. Circumference of the circle, the length is the same way, how many segments you have in a circle, the same way this length, circumference length, you have to divide it into 12 equal segments. So 125.7 has to divide it by 12, you will get the 12 equal segment. Otherwise you follow the construction procedure, okay. You have to follow the construction procedure, draw a slant line, okay. Get the 12 segments in this one, okay. Drill your drafter from any angle, get 12 divisions. Millimeters. By taking 8.7 centimeters. while measuring scale. Okay, you can okay, nearing to 126 you can mark it. You don't have the 0.7 in your scale, so nearing to 6. Okay, quickly you divide it. Okay, this construction plans, make it fast, it's over. I have to draw tangent lines for each segment. Listen all. See here, the segments I have 12 segments. Okay, I have drawn a line, horizontal line. That horizontal line is nothing but a tangent line for the 12th segment, isn't it? For the 12th segment, the horizontal line I have drawn is nothing but it is a tangent line for the 12th segment. So tangent line is nothing but for the 12th segment, this is a line going through the center. For this line what I have drawn, it is perpendicular. Right, that is nothing but the tangent line. So similarly for the 12 segments, I have on the 12 circumference points on the circle, I have to draw tangent lines for that points. Okay, in the circumference of the circle. Okay, so for a circle, if I have any point, how to draw the tangent for that? If I have a circle, I have a point, say M, I have to draw tangent to this. How I can draw it? So draw the M with the center, join it to the center. So to this line I can draw a perpendicular. To this line I can draw a perpendicular. That is nothing but my tangent. Okay, similarly I have 12 lines goes through the center. Right. So I can conveniently draw tangents to that. Okay, the same fashion, how I can do it? From 1, 2, 3, okay, all the segments I have to draw tangent lines in the negative direction. See here, in the negative direction in the sense, so I can keep my drafter, okay, easily you can keep your drafters one scale to this line, okay, segment line 1, the other scale will be perpendicular. Using that scale, I can draw a tangent line. So perpendicular to that, I can draw a tangent line from segment 1. So this is perpendicular. Similarly from point 2, so I can fix my drafter along this line to the center. The other scale will be perpendicular. Using that I can draw a tangent line. So you have to draw the tangent line in the negative direction. See here. Okay. So this is perpendicular. I can draw a tangent line. For 3, this will be my tangent line. For 4, the negative direction, this will be my tangent line. 5. So carefully using your drafter, you have to draw this tangent line. Here, 6 is perfectly horizontal. So this is my tangent line for 6. For 7. For 8. See here, these tangent lines, okay, you have to, using your drafter, you have to draw it. How I have to draw it in the negative direction, I am drawing the tangent line, not in the positive direction, in the negative direction. So this is my 11th tangent line. The another one, this horizontal line, what you have drawn already, this my 12th segment tangent line. Horizontal line what I have drawn already, it is tangent line for the 12th segment, right? See here. Now after this, I have to mark the points of the involute. Okay, here as like your polygon, you cannot draw it using your compass. You don't have a constant radius in between the tangent lines you have. Right? The radius of this involute for a circle, it will be varying from point to point. Okay, it will be continuously, it will be varying. Because the circle is a again it's a polygon, it is an infinite polygon. Right? So the infinite polygon in the sense is the radius of the involute, it will be constantly, it will be varying. So I cannot use my compass to draw a segment, okay, various 12 segments. It will be drawn using only your free hand, okay. How I can do it? I can mark the various 12 points in this tangent line. How I can mark 12 points in these 12 tangent lines? Already you have 12 segments here. Okay, 12 segments you have here. So what I can do it? The first length from point P, first segment, what is the length you have? You can measure it in your compass. That you can transfer it from point 1, segment 1 to that tangent line. The second segment length you can measure it to your compass. That you can transfer it from segment 2 to that tangent line. Okay, so this segment is nothing but this. This is my P1. So the second segment is nothing but this. This is my P2. Third segment, P3. Fourth segment, P4. So is it clear? How I am marking these involute points? It's nothing but the divisions you have in the 12 divisions. Okay, each segment length you know, you measure it in your compass. The first segment length you have to transfer it from the first tangent line. Okay, tangent line drawn from the first segment of the circle. The second segment length from point P to second segment length. Okay, that you have to transfer it on the tangent line drawn from the second segment. Okay, similarly for all the points you can get it. Okay, all the points you can get it. So I can smoothly connect these points, okay, 12 points to get an involute of a circle. Okay, so here point 5. This is my point 5, point 6. Point 7. First you get it lightly, then once you have got the smooth curve, you darken it using your H pencil, right? Now the tangent and normal, the point location is given. What is the distance of the point from the center? 90 mm. You measure it in your compass, in between which 2 points. Check 90 mm from the center, approximately you tell. See here, listen. The 90 mm point from the center, it falls in between P8 and P9. Okay, see here, somewhere here, it falls. So this is my point. I am interested. This is So this point to the center, the length of this point from the center, it is given 90 mm. See, listen all of you. How to draw the tangent and normal? Okay, from center to this point is 90 mm. Okay, it falls in between P8 and P9. Okay, how to draw tangent and normal? It is different from polygon. See here how I can draw it. Listen all of you. Using OM as diameter, using O and M as diameter, you draw a circle, not a circle, you draw a semicircle in the direction of the involute. How I can draw it? OM is 90 mm, you mark the center for OM, that is 45 mm. So 45 mm I can mark the center. This is my center, right? O. Using this center, I can draw a semicircle along this direction. See here, this is the semicircle I have drawn using OM as diameter. That is 90 mm as diameter. I have drawn a semicircle in the direction of the involute. See here, this circle, where it intersects the original circle, it should intersect in between 8 and 9, where you have the point, actual point on the involute. It falls in between 8 and 9. The semicircle also, it has intersect the original circle in between 8 and 9. Okay, where it intersects, that point you mark it, you connect that point to M. You connect that point to M, that is nothing but what? Normal. The perpendicular to that will be the tangent. Is it clear? So drawing tangent and normal for a circle, involute of a circle, this is a procedure. For polygon, procedure is simple. Here you have to mark the point first of all. Then center to that point, what is the length? That is the diameter. Using that as diameter, to draw a semicircle along the direction of the involute. Okay. So that semicircle will give you an intersection location on the original circle on the same segments where you have the point. In between the same segments where you have the point. M is in between P8 and P9. The intersection point also will fall in between the segments 8 and 9. So this is the point I am interested M. So I can connect that M and M. That is my tangent, normal, sorry. So perpendicular to that is my tangent. So perpendicular to that I can draw a tangent. So a portion of normal and sec tangent you can calculate. This is my normal, this is my tangent. Then you have to dimension the given data. You see here I can dimension the 90 mm. This is my 90 mm. So this is 90. Then the diameter of the circle, you see here, instead of diameter I can dimension the radius. I already have an extension line here. What I can do, this will give me the dimension of the radius of the circle. Is it clear? So instead of diameter, we can show the radius. What will be this length? That is nothing but the radius of the circle. Okay, instead of dimensioning the diameter, I can show that 20. Okay, I can show that 20. So this is how we have to draw the involute of a circle and draw the tangent and normal. Okay, do it.